2.2.3 Build pipelines, stages, quality gates, and validation. In this chapter, we're going to look at what a CI/CD pipeline really does, how code leaves a developer's laptop and eventually becomes something real that users interact with. If you've ever worked in a team where releases were done manually, you probably remember the feeling. Someone copies files. Someone restarts something on the server. Someone watches logs and hopes nothing goes wrong. And everyone quietly thinks, please, just don't break. CI/CD pipelines were invented to remove exactly that feeling. They exist so releases stop depending on bravery, improvisation, and luck, and start depending on engineering. A pipeline is simply the path every change must travel. One path, always the same, no shortcuts. Let's follow that path together. From the moment code is written to the moment users actually touch it. Everything really begins the moment someone commits code. That single action is what wakes the pipeline up. The pipeline wakes up automatically. No one presses run. No one kicks off a script manually. Systems like Jenkins, GitLab CI, or GitHub Actions detect the change and begin the journey. Automation means fairness. Every change, small or big, is treated as potentially risky and goes through the same checks. And that leads us into the first big transformation. From there, the first real transformation happens. The code has to stop being just text and become something the system can actually run. Source code is just text. Developers understand it. Computers don't run text. In the build stage, the CI system takes that text and turns it into something executable. Sometimes that becomes a compiled binary. Sometimes it becomes a packaged web app. Very often, it becomes a Docker image, a kind of portable box that contains both the application and everything it needs to run. Once created, that image is placed into a registry, maybe Docker Hub, maybe GitHub Container Registry, maybe a private company registry. And it simply waits there. A mature team follows one simple rule. Build once, use everywhere. The artifact built here is the same artifact that goes through testing, staging, and production. We don't rebuild just before release. We don't tweak it later. Predictability begins when the artifact becomes stable. Once we finally have something that can run, the next natural question is whether it behaves the way we expect it to. And here's the key idea. Tests are not there to blame developers. They exist because humans simply cannot foresee every side effect. Different types of tests run automatically. Some verify small pieces of logic. Some verify how components interact. Some simulate real user behavior, often using tools like Selenium or Playwright. The principle is simple. If something is going to break, let it break here, early, quietly, and cheaply. A bug caught in testing costs minutes. A bug caught in production costs weekends, incident calls, and apologies. But even when tests pass, the pipeline doesn't simply trust the change. It reaches a set of automated checkpoints that decide whether it is allowed to move forward. They are called quality gates, but testing alone is not enough. That's why pipelines introduce something engineers call quality gates. A quality gate is a checkpoint that asks, is this change allowed to move forward? At these moments, specialized tools step in. SonarQB analyzes code structure and smells patterns that historically cause failures. Security scanners such as SNCC or Trivy examine dependencies and Docker images for vulnerabilities. If they find something dangerous, the gate simply does not open. The pipeline freezes the change where it stands. No debates, no temporary exceptions, no pushing risky code just this once. Without quality gates, a pipeline is simply a fast script. With them, it becomes a guardian. After that, the pipeline steps back and looks at the bigger picture, asking not just whether the software works, but whether it is actually safe to release. Testing asks one question: does the code behave correctly? Validation asks a much wider one: is this safe to release into the real world? During validation, the pipeline examines everything around the software, not only inside it. Configuration linters verify formats, so a single typo doesn't crash the system. Secret scanning tools look for accidentally committed credentials and tokens. Database migrations are validated before they ever touch real data. Some teams even run lightweight performance checks to see whether a new feature might overload the system once real users arrive. Here, environment becomes just as important as application. Later, when we talk about infrastructure as code and config as code, you'll see why they make validation far easier and far safer. For now, keep one sentence in mind. Testing protects correctness. Validation protects safety. If everything still looks good, the change finally leaves the lab and moves into staging, a space that feels almost like production but still gives us room to observe. When a change has successfully passed tests, gates, and validation, the pipeline labels it as ready. Ready doesn't always mean immediately released. Most teams first promote the new version into a staging environment. There, it runs in conditions very close to production, often managed by Kubernetes, while tools like Argo CD or Helm ensure that the environment stays exactly in the desired state. Nothing is thrown into production blindly. Engineers watch metrics. They compare behavior. They look for signals that something unusual might happen later. Sometimes a person still approves the final step. In other setups, the pipeline automatically deploys when everything turns green. How exactly rollout happens, gradually, side by side, or to a small group first, we'll explore in later chapters when we discuss deployment strategies and zero downtime techniques. For now, remember, the pipeline doesn't just copy files to servers. It orchestrates a safe rollout. What makes this entire flow powerful is that when something does go wrong, it happens early, it happens clearly, and it happens in a place where it can't hurt users. A strong pipeline does not hide failure, it encourages safe failure, early, fast, and informative. When something breaks, the pipeline explains what broke, where it broke, and usually why. And it tells the developer within minutes, while the context is still fresh. Fixing problems early is cheap. Fixing them in production is painful, expensive, and sometimes public. That fast feedback loop is one of the quiet superpowers of CI/CD. None of this reliability appears by accident. It comes from a set of disciplined habits that teams repeat every single day. Behind everything we've discussed sits discipline. Pipelines are written as code, reviewed like any other code, and kept in version control. They run in isolated environments so that results remain repeatable. The same artifact travels unchanged from build to production. Environments are defined consistently instead of being manually tuned on each server. And over time, something subtle happens. Releases stop feeling like risky missions. They start feeling like calm routines. And calm routines build trust. And when people ask which tool is actually responsible for all of this, the truth is that it isn't one tool at all, but a group of them working together in sequence. People often ask, which single tool is the pipeline? The answer is none, and all of them. One system detects changes and runs the stages. Another builds and stores artifacts. Another runs automated tests. Another scans for vulnerabilities. Another manages controlled rollout into production. They are not random pieces. They form one coordinated highway from code to users. In the end, when people talk about CI/CD, they aren't really asking about configuration files. They're trying to understand what problems this pipeline truly solves. When someone asks about CI/CD pipelines, they usually aren't looking for fancy dashboards. They want to know why pipelines exist, what each stage actually does, why quality gates refuse risky changes, how validation is different from simple testing, and how all of this reduces risk instead of adding more complexity. Once that clicks, CI/CD stops sounding mystical. It becomes visible, understandable engineering. And this understanding is exactly what interviewers listen for. They don't just want to hear that you use CI/CD. They want to hear that you know why each stage exists, what risks it controls, and how quality gates, validation, and automation work together to make releases safer instead of scarier. When you can explain the pipeline in those terms, you're no longer just describing tools. You're showing that you think like an engineer who understands production. And now that we know how changes travel through the pipeline, a natural question appears. What exactly are we moving through this pipeline? And how do we make sure it behaves the same way everywhere? That question leads us to the next chapter: Docker images, artifacts, and reproducible builds. End of 2.2.3.